grade 11s, we meet again and we continue with functions. And now guys, remember that your functions, 60%, almost 60% of what we do in matric, it comes from your grade 11. So we're not going to be running away from functions, and let's just get to the business. Today we're doing the effect of changing parameters on functions, okay? Now, remember last year, guys, you were just doing basic functions, your straight line, your parabola, your hyperbola, and so forth, exponential ones and stuff. But now we are going to be adding some of the things on the functions that you did last year. One, we have some possibilities of transformations, okay, that we can make to any function, right? So number one, you've got your function. For instance, last year you had y equals to maybe x squared, right? But now, this year, you can have your y, even though you did this one last year as well, x squared plus 2. Now, what is happening to that graph that is given when you added 2, moving it up 2 units? Or you have your y is x squared minus 3. You take it down 3 units, okay? So, a graph, for instance, you have this as your parent function, right? Now, if you take it down, I mean, you're taking it up 2 units, so this, the origin, you see, it's not a naught. So here, it's going to be 2. So your new one is going to be there, all right? If you've got minus 3, so it's going to turn the something like that, okay? So you take it up or down by adding or subtracting, all right? So that is your f of x plus a. Right, now coming to the next part, the f of x plus a, all right? So your f of x plus a. So what are you doing? The first example, you were dealing with the up and down, right? And then now the f of x plus a, looking at moving it along the axis, okay? So you've got graph like this, which is your normal y equals to x squared, okay? Now, but if I say this is f of x equals to x squared, and then now I'm putting something here and say x minus 2, right? So we're doing the horizontal one, but now watch, this is x minus 2, so this point you are moving it 2 units. It's still the same graph, okay, but shifted. If this was a plus, sorry, it shifted 2 units to the left. But if it's a minus, you're shifting it to the right 2 units, because you're looking at your x plus 2 equals to naught, x is minus 2, okay, as our turning point, right? And then on we'll have your f of x minus x, and then we'll be checking all those where we're reflecting the graph. And then what happens if you've got a minus f of x and your f2 minus x, which is what you're going to be receiving in grade 12. All right, so for today, we'll look at the effect of the transformation on a quadratic function. Okay, right, now let us start with this one. You've got your f of x, which is a quadratic function, all right, and that is, we normally call it a parabola. Now what we are doing here is, you've got a g of x equals to f of x plus a, all right? Now, we're saying plus a plus any constant, okay? So, what is happening is, I'm going to have this graph is now moved. Can you see? It's moved up 2 units, okay? So if we give this a name, this is your f of x, right? But now, when I'm moving it 2 units up, this will be your f of x plus 2. Whatever equation that you have for the graph, and then you'll add it 2, then you'll get a new function. Now, if I were to take it down, right, so what's going to happen is I'm going to subtract, right, this is 1 point something, so I'm going to subtract, it's going to be f of x, this is f of x minus maybe 1.5, something like that, okay, right? Now, we move on to g of x equals to f of x plus a. What is happening when you are dealing with a graph and then on the x you are adding or you're subtracting something? Okay, let's check what happens. Okay, so I have this quadratic function. I am going to move it, so you see I'm moving how many, let's check here, 3 units to the right. Now remember, 3 units to the right, so it means that your x is equals to 3. So if you look, this is your f of x, all right, which is maybe for this one, the first part, the mother function was f of x equals to x squared. What are you doing to this is you are moving it 3 units to the right, so it's x minus 3 all squared, right? And then now, let's say for instance, I take the very same graph, bring it back, and then I'm moving it okay, that's 1, 2, 3, 4, 5. I'm moving it 5 units to the left, okay? So what you're going to be saying is this is f of x, right? It's going to be inside the example, so it's going to be x plus 5 all squared. What's happening is this new function, you're looking at the inside, that's x plus 5 all squared. So x is equal to minus 5. So the x value, the shifting is at 5 there. Okay. Right, let's take it back. And then we move on to the next one. Right. What happens if you've got a g of x equals to f of minus x? All right. Now, if we were to look, okay, this thing doesn't want to move, all right, you are reflecting this, and it's going to nicely touch there. So you've got y equals to f of minus x, all right? So you're reflecting it about the y, okay? So, and then here, you've got your g of x equals to minus f of x. Right, guys, this you did in grade 10. Let's take just one example. You've got, for instance, f of x equals to x squared. This graph looks like that, all right? But now, when you've got your, let's say now it's g of x equals to minus x squared. What is happening? You've got that. All right, so now what's happening here is now it should okay, it should be looking like this. Okay, so something like that, because you've got the positive one, and then this one should be a negative one. And then if you look at the one, it's called an inverse, right? Interchanging your x and y, but you're going to see this in grade 12, all right? So where there was an x value, then if we put a minus sign in front of every y value in the expression, then the graph is reflected around the x-axis. That was the one that we just did. Okay. All right, guys, I'm going to give you these problems because last year you were able to draw the graphs, and most of you were using calculators and tables and so forth, and it was not that complicated in your grade 10. So what I'm going to ask you to do is to make a neat sketch graphs of the following functions, show clearly any intercepts, turning points, or asymptotes. And we've spoken about asymptotes last year. So I'm giving you 3 minutes to work on these problems, and then we take a break, and then after the break, we're going to be doing them together. Let's take 3 minutes. All right, welcome back, guys. Let's just check if we're doing a correct thing or an incorrect thing. All right. We have this graph. Now, what you're going to be doing here is we start by the parent function, which is your y equals to x squared. Okay. We know that the graph y equals to x squared looks like this. Okay, right? You will be accurate yourselves. Now, we are treating, this is y equals to now minus x squared. Can you see that I've started with a parent function? Now, I am dealing with that minus. What's going to happen to our graph? It's going to be facing down. Okay, right. You'll check with me, guys, that it's 0 and 0, 1 and 1, 2 and 4, and so forth. Okay, and then now we come here. This is x plus 2. What is happening to our graph? We're moving it horizontally, right? But it's going 2 units to the left, right? Because that's a plus, so your x is minus 2. So our graph comes here, right? Guys, don't mind my sketch. It should be touching there, all right? So we've dealt with the x plus 2. Now we come to that, the plus 4. What is happening? The graph up by 4 units. So from where it stands, 1, 2, 3, 4. So it means that that point is somewhere there. So your graph will be looking like that. Okay. It's not sharp there, guys. It's a curve. You see, we've grown up and our hands are not that steady. Okay, so your graph should be looking like that, and we will be looking at your turning point and so forth, but we're just focusing on the transformation for now, and later we'll be knowing that the turning point is minus 2 and 4 and so forth. So that's how you go about it. You make sure that you start with your parent function, do the transformations on the parent function. All right, this was y equals to x squared, and then now minus x squared, and then from there you added 2, okay? So you're shifting it to the left 2 units, and then plus 4, you're moving it up 4 units. All right, guys, let's take a break, and then we come back and we continue with our work. Welcome back, guys. Let's just continue with our work, and I'm sure you've got some cup of coffee or some water. Let's proceed. The first part, we did a quadratic one, and we just wanted to refer you back to the hyperbola as well, because you did it last year, and it was only just in the form of y equals to k over x plus q, all right? And now, what you noticed last year is that this graph has got asymptotes, okay? And then, which was, okay, it was derived from isiZulu, asymptotes, asymptote that doesn't touch and whatnot. So you've got y equals to k over x plus q. So the asymptotes here was 0 and q, right? X equals to 0, and then your y equals to q, where your vertical and your horizontal asymptote. Now, look what has happened. Now, like we were talking in those graphs, the parabola, there's something they are doing now to us in grade 11. You've got y equals to k over x plus p plus q, right? We still keep this asymptote, all right? Now, you have that, it's not like it's a new one. It's been there, it was x plus 0. So your asymptote here will be x equals to minus p, and then your y is your q, all right? So now, quickly, we still continue like last year, all right? Your graph is y equals to 9 over x plus 2 minus 1. We go straight to the ones that the graph is not going to touch the lines. So it's this one, x plus 2 equals to 0. Then x is minus 2. And remember, how do we represent the asymptotes with the dotted lines, right? If you've got it drawn to scale, okay, right? So x is equals to 2, and then your y is equals to negative 1, right? Y is negative 1. All right, and then you are also checking which quadrants does this graphs fall. And now, guys, remember what's going to help us is to find the x-intercept and the y-intercept so that we'll be able to see the shape of that graph. Now, for your x-intercept, you make y 0, and for your y-intercept, you make x 0. Right, for y, you make x 0. So you get 9 over 2, which is 4,5 minus 1. So y is 3,5. So 1, 2, 3. So your y is somewhere there. And then for x, you make y equals to 0, and then you solve for x. Right, if you solve for x here, guys, you have your 0 is 9 over x plus 2 minus 1, transpose the minus 1, and then you multiply by x plus 2 throughout. You get x plus 2 is 9, then x is 7. Right, then you go to your x, which is 7, 2, 4, 1, 2, 3, 4, 5, 6, 7. Right, and then it's not going to touch the asymptotes. And then you can check the other points, guys, but your graph should be looking like this. Okay, it's going closer, should be a nice curve. Let's just try again. Okay, right? So you've got y was 3,5, right? So you've got 1, 2, 3, 3,5 is there. Then we said 7 is going to be somewhere there. And then I've tried. Okay, so but your curve should be like this, but not touching. It's a very funny curve. Not touching the asymptotes. So the rest of the graph should be this side. Okay. All right. So that is your hyperbola. Now we move on to the next one, and I thought we should be talking about this graph. Y equals to 2x squared minus 3x minus 2. All right? Now, I'm going to give you a chance because you have a little bit, like you know what needs to happen here. One, you need to have the x-intercepts, right? How do you find your x-intercepts? You make y 0, and then you solve for x, okay? And then 2, you need to find your y-intercept. You make x 0. Your turning point in grade 11, remember, you have x equals to minus b over 2a, all right? So that is minus b over 2a is your x value of the turning point for a parabola. And then what do you do next? You take the x value, you substitute it back to the original graph or equation, right? Now, let us start. You've got y equals to 2x squared minus 3x minus 2, okay? All right, guys, no, I can hear you guys, you want to try it first on your own, but I'm going to just give you only 2 minutes to look at this problem, and then we go straight to it because there's quite a lot that we need to cover, right? Just take 2 minutes and work on it. 3 things: 2 x-intercepts, 1 y-intercept, and a turning point. Let's go. 2 minutes. All right, guys, those three things. First one, y-intercept, which is easier. For y-intercept, you make x0. And then if you have 0, 0, then it means that your y is minus 2. So you've got x is 0, and then y is minus 2. So this is, goodness, don't worry, it's there. Right, so x is 0, y is negative 2. Now, for x-intercept, you make y0. So you've got y0 equals 2. You factorize the 2x squared minus 3x minus 2. And if you factorize that, you get 2x, x, 2, and 1 minus and plus. So x is a half, or x is 2, right? Okay, so x is a half, or x is 2. X is x is half, or x is negative half. Guys, you must be extra careful here. This is 2x plus 1. You are the ones who are showing me these wrong answers. X equals to negative half, or x is 2. So negative half is somewhere there. All right? Now, we continue. We said, now your turning point, remember in grade 10, your turning point, it was at the origin, right? When x is 0, it was turning at the y cut. But now we've got x is minus b over 2a. And remember, you've got, this is a quadratic function, y equals to ax squared plus bx plus c. So b is negative 3. So b is negative 3 all over 2. A is 2, so you've got 3 over 4. So, in other words, 3 over 4, it's going to be small, 3 over 4, that is our mirror image, okay? All right? And then now, next, we should have made the scale to be a little bit bigger. And then you take this and substitute to the original, okay? So you've got y is 2 bracket 3 over 4 squared minus 3 bracket 3 over 4 minus 2, which gives us y equals to 9 over 16. That's 18 over 16 minus 9 over 4 minus 2. Y is, you can work it out for me, that's 9 over 8, 9 divided by 8, and then minus 9 over 4, and then minus 2, which gives us negative 25 over 8, negative 3,125, negative 3,125, right? So this was 1, 2, so 3, so it's something like this. Then your graph, you have to be very careful, guys. And so you've got your 3, that's your turning point, x-intercepts, and your y-intercept. But we'll get to more details later. Okay. Now, the next problem, as we continue with these transformations, we're asking ourselves some questions. If you're given now, what will the new equation of the parabola y equals to minus x squared plus 2x plus 3 become if it is shifted 3 units to the left and 2 units up? Okay, let's work on this problem together with your partner, and then we can look at it together with me. All right, so you've got 2 minutes. Grade 11s, why are you this slow today? Right? What I'm going to do now, because I can see that some of you need some extra time, we're going to go for break, and then we come back and look at this problem together. Let's go for break. Okay, welcome back, guys. I've given you enough time. Let's look at it together now. So you've got y, y equals to negative x squared plus 2x plus 3. Okay. Now, they're asking us to find the new equation, right, of the parabola if it's shifted 3 units to the left. Now, we have to be extra careful. 3 units to the left. Remember, you have y equals to, for instance, x squared. If I'm moving it maybe 5 units to the right, so this is going to be y equals to x minus 5 squared. And you see that the one that is affected is the x. So now we're moving it 3 units to the left, okay? So this is going to be y equals to minus bracket x plus 3 squared plus 2 x plus 3 plus 3. Right, now let's do it. Okay, so this is out. Now, and 2 units up, the very same graph that we have done, the 3 units to the left, you move it up 2 units, okay? So if it's up by 2 units, go back to the start. You've got f of x plus a, right? So you're adding a 2 there. So it's plus 2. And then from there, it's easy. You then simplify. So this is y equals to minus x squared plus 6x plus 9 plus 2x plus 6 plus 5, which gives us y equals to minus x squared minus 6x minus 9 plus 2x minus, is it 11? This is 2x plus 6 plus 3 plus 2. Yeah, it should be looking good. So you've got y is minus x squared minus 6x. There's 2, your like terms, guys. This will be your minus 4x and minus, it looks like it's going to be minus 20. Just double check, okay? So you've got minus x squared, right? X squared plus 6x plus 9 plus 2x plus 3, which is your 2x plus 6 plus that 3, okay? And then plus 2 units, 2 units up. And where am I getting this 5 from? This is plus 6. Let's just fix that. Plus 2x plus 6. All right. Plus 3 plus 5. Okay. Which is correct. So you've got plus 11. That's minus 20. So it's minus x squared minus 4x minus 20. Just check your simplification and then you are fine. All right. So now we move on to the next one. Same thing applies. What will the new function be if f of x is 3 over x plus 2 minus 1? If it's shifted 2 units to the right. Now, remember, what is going to be affected is your denominator, your asymptote. At the present moment, you've got your x plus 2. If it says 2 units to the right, it means that you are subtracting a 2. So you've got that the very same f of x, which is 3 over x plus 2, but what you've done, you subtracted a 2, right? Minus 1, which is originally there, and then 7 units down, okay? So that plusing, remember, your g of x when you started, that's your f of x plus a. So you take it down 7 units, so it's minus 7, which simplifies to 3 over x minus 8. So your f of x is that. Now, the new f of x. I suggest after you've done this, you draw the two graphs, and it has to show you that this graph has been shifted 2 units to the right and then 7 units down. Okay, right. We look at this problem. The one before this one, we'll do it after. What will the equation of y equals to minus 3x squared plus 5x minus 4 become if the origin moves to minus 2 and 5? Now remember, this is your origin. So now it means that what has happened is you have your minus 3 bracket. The affected part will be your x again. So you've got your x minus 2 squared plus 5 bracket x minus 2 minus 4 minus that 5, which gives us minus 3 bracket x squared minus 4x plus 4. You'll simplify, plus 5x minus 10 minus 9, which is y equals to minus 3x squared plus 12x minus 12 plus 5x minus 19, and that is your y equals to minus 3x squared plus 17x minus 31. Okay, so your new equation, when the origin now is moved to the negative 2, 5, right? It was here, went to negative 2, and then 5 up there. So what happens to your graph? Your new graph is going to be minus 3x squared plus 17x minus 31. Okay. Right. Now, you need to find the equation of the parabola which has a turning point at minus 3, minus 4, and passes through the point minus 1, 12, and give your answer in the form of y equals to a bracket x minus p squared plus q. Now, guys, please be reminded, beginning of the year when we're busy with quadratic equations and so forth, all right? So you were given a chance to be able to solve for x by first completing a square, all right? Where you had to work with y equals to ax squared plus bx plus q, and later you ended up getting your quadratic equation, x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. So you are using that now. Your y equals to a bracket x minus p squared plus q. Now, your p and q is your turning point, okay? So your turning point is p and q. Now, you've got x minus p equals to 0, and then you're solving for x, for the x value of the turning point. Your x is p. Now, for instance, if I am given x plus 2 all squared, what is going to be the x value of the turning point? It's x plus 2 equals to 0, x is minus 2. All right, so now here you given the values, the value of p and q. So your p is minus 3, q is minus 4. So you have y equals to a bracket x minus 3, which is a plus 3 squared minus 4. All right. Now, once you have substituted that, they are also telling you that it passes through the point minus 1, 12, right? Now, what is that point? That's your x and your y. Y is 12 equals to a bracket x is minus 1 plus 3 all squared minus 4. So this is 12 equals to a bracket 4 minus 4, all right? And then transpose the 4, you get 16 equals to 4a. Then your a is 4. Right. Now that you have found the value of a, you now have your a your P, and your Q. And that's what we are interested in, okay? So you just need to substitute now. Your A is 4, so therefore your graph in the form of A into x minus P squared plus Q is 4 bracket x plus 3 all squared, right, minus 4. So your final graph is y equals to 4 bracket x plus 3 all squared minus 4. So your turning point is minus 3 minus 4. Right. Now, just familiarize yourself again, because some of us, we are taught, and then when we're moving to the next chapter, we forget about what we did. Guys, this links whatever we did in the beginning of the year and the other years, it comes back together. So you need not to forget the things that we have done. So as you can see, your solving for x by first completing a square, it's coming back now, and you'll be using it more this year as well. Okay. Now, we look at the next problem. What translations took place if the graph of y, there's a mistake there, of y equals to negative x squared plus 5x minus 4. Now, what we need to do is to compare the turning points, okay? Right. Now, so you have, this is minus x squared. Now, remember, when you're completing a square, take out a common factor. This is x squared minus 5x plus 4, which simplifies to y equals to minus bracket x minus 5 over 2 all squared plus 4 minus, this should be 25 over 4. Okay, guys, now watch, very important, when you're completing a square on one side, remember when it was an equation, you were transposing and so forth, but you're doing it on one side, you are adding something which is 25 over 4. You have to subtract it to make it the original problem, okay? So you get y is, simplify this, it's minus into x minus 5 over 2 all squared, that's plus 16 minus, so it's minus 9 over 4, and then you remove the square brackets, you've got y is negative x minus 5 over 2 squared plus 9 over 4. All right, now then we look at the next graph. What's going to be the turning point? You have your y is x plus 2 squared minus 12 minus 4, which is x plus 2 all squared minus 16. Now you need to compare the turning points. Okay, guys, what I want you to do is you look at this turning point, what's happening. The turning point for this one is x equals to 5 over 2, and the turning point of this is x equals to minus 2. You compare the two x turning points, and then your y is 9 over 4, and then this side is y equals to minus 16. Now, you will be able to determine what happened to your graph. The initial one is 5 over 2, and then the next one is negative 2. And then the initial one is 9 over 4, and then the next one is negative 16. So you need to determine what has happened to those two graphs. But guys, because of time, I'm sure you'll be able to do it and work on your notes, and there's revision solutions as well. But for me, let's meet next time. Bye-bye.